Thank you, everyone, for coming to Strait Science tonight. Strait Science is a UAF, University of Alaska Fairbanks, public science series put on by Northwest Campus here in Nome, and also by UAF Alaska Sea Grant, also here in Nome, and you're in the Nome office of Sea Grant tonight. So both Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the St. Lawrence Island Yupik, Bering Strait dialect Inupiaq, and Central Yupik peoples. Tonight's speaker, he gets a Medal of Honor for dealing with the glitches to the point where he is on, and he's going to remain a little mysterious, but maybe we'll figure it out at the end for questions and things like that, so you can get a view of him. But tonight we have Mark Houston, and he has a very nice write-up, and I'm going to read it because I don't know anything about heat pumps and hydroponics. And Mark is a Alaska Energy Rater, a Passive House Energy Rater, net zero building design consultant, and distributor of products that make buildings carbon negative. He's done many projects in the Northwest Arctic Borough region and energy ratings in Kotzebue, Gamble, Bethel, and Utqiagvik, and almost everywhere else in Alaska. So no stranger to the region. I'm interested in hydroponics. It became a topic of discussion here in Nome as prices were getting higher and higher in the store. And I think I was saying I saw an artichoke for $8. You know, that's where we are now. And I'm very curious. And Mark was kind enough to talk about heat pumps and hydroponics because he's worked in this region on both issues. With that, Mark, I hope you've had a chance to catch your breath and jump right into it.
I am ready.
Thank you so much for coming. We're going to have all learn something new. Go for
Thanks,
it.
everyone. Thanks, Gay. I am, wait a minute. There we go. So my background, as Gay said, I've been a general contractor through most of my life. I ran a 4-season sunroom business years ago in Pennsylvania. My brother and I had a business in Seattle called The Idea Builders, Inc., small contracting company. When I moved to Alaska, I became an energy rater. I was also teaching as an adjunct at UAA's CM program, construction management. And I have taught some classes for SAVIC. I'm a member of AK Heat Smart as their energy rater for when people, they're based in Juneau, and there's a lot of heat pump work going down in Juneau and in the what we would call the warmer climates of Alaska, but it is not just for them. So they're having me work up in the South Central area. I'm a certified passive house energy rater, which means that Alaska Housing's best building doesn't even get close to these passive house projects. Thorsten Schloop in Fairbanks was the one who really caught my attention, and I decided to become a certified rater for them. I've worked in all the different different regions listed there. Northwest Arctic Borough, Bering Straits Housing Authority, Bristol Bay Housing Authority, Aleutian Housing Authority, Otna Region, Tyonek. I do consulting for new buildings and for retrofits on homes to get them to net zero. And I, by default, had to get into the building materials business because nobody could find the products that go into these super efficient buildings. And I put myself out there, and my wife begrudgingly allowed me to do it, but I am now bringing in some really cool products that help people make super efficient buildings. And this is what prompted me to start bringing in heat pumps, because when you drive the heat loss down in the building, you get a really low heat need. You don't need a big boiler. You only need something as small as a heat pump that works off electricity, which can also work off of solar or hydro or whatever you have regionally. And I always do the math, and I always make sure that it's going to pencil out for people, or I'm not going to do the job. So you can see all those different projects I've got around the state. It's pretty long list. There are probably some more in there I forgot to put in. So I'm going to start with solar, because that's the big savior for all of us. Actually, what's going to save us is solar, wind, hydro. Whatever you have in your region that will bring your electric costs down. And the big question is, what's the highest and best use of solar? Why are we putting in solar in regions or on people's homes? And what's the highest and best use? Well, think about it. We've got lighting now that is 4 watts at most per fixture. It's certainly not that with LEDs. We still do have water heating needs, and we have heating needs, and we have washing machines, and we have dryers and other things that are electric. So the answer truly is the highest and best use of the electricity from solar panels is heat pumps, because they solve one of the biggest problems we have in every house in Alaska, and that is heating and hot water. Hot water is 30% of your load for your house, and paying to use oil in your region just isn't cost effective like a mini split is, but mini splits only make heat.
So
So
Mark,
yeah,
Mark, this is Gay. I'm new to this topic myself. I'm more of a blood and guts kind of topic person, but
yep,
can you explain what is a heat pump?
I'm getting to that.
Oh, okay.
So
Thank you.
this is a list of types of heat pumps. So a heat pump, let me go down one and show you. That's a heat pump on the outside of a building. It takes the heat out of the air, runs it through a compression cycle, pulls. The heat can be as low as 40 below. There's still heat in the air. And it puts it under pressure with a scroll compressor, and it moves that to the inside of the building. In this case, this is a mini split that you see that tube that goes to the left and then up and into the house. That is the tubing that carries the heat into the house, and then it releases the heat into the house on one of these. This is a high wall head. This is an emitter, and the other option would be to release it to a water heater as hot water. So you have 2 types of heat pumps. So I'm going to go back up. So mini splits have a single head like the one you just saw. Multi-splits have the capacity to have more than one head, typically 2 to 4 or 5. They're much bigger systems, and I'll show you some of those in a little while. Fishing boats have a type of a heat pump in it where they're taking seawater and dropping the temperature of the seawater to better refrigerate their fish and keep them from spoiling on the boat. We have ventilators, which we call HRVs, and there are a couple of products out there now that have heat pumps built into them since they're already moving heat around the building, it's just logical to do that. There are also, instead of just electric dryers, there are heat pump dryers, and they are more efficient than a regular electric dryer. So a heat pump typically is about 3 times more efficient than the equivalent direct product that you're trying to solve for. So with a dryer, you're going to save about 2/3 of your cost of drying your clothes with these new types of dryers. We use heat pumps for heat preservation, and that's a pretty easy one. We all have refrigerators and freezers. They all have a heat pump in them. Air conditioners are a kind of heat pump. We also have, for heating in buildings, ground source heat, heat recovery with mini splits or with heat pumps. And a new wave is wastewater heat recovery. And this is a fun one that people like to get a giggle about. It's actually using sewer water because it's warm, and they're extracting the heat out of that to create heat for buildings. Typically, these are put into condominium complexes, apartment buildings. They're even using them in Scotland for district, so like whole town heating systems. They're taking your effluent and using it to heat buildings. It's an awesome, awesome science. And I just love what is happening in this industry. So that's a mini split, and that appears to have one unit inside to heat this building. And I can't remember where that was. That was years ago. I think it's in Kotz. This one is in Atka. I was commissioned to do this. I love Atka. It's beautiful down there. This is a 2-head unit. It could have 4 heads. So it is on their office building, their city office building, which has the other half of it. It's a duplex. The other half is a place for rent for people who come out there to visit. So it's kind of like an Airbnb that the city runs. But they put it on their office side because they wanted to test it out. They got a grant to do this. So I showed you that. That's what is transferring the heat from outside into the building. And they basically run pretty much 24/7 in the wintertime. That's not a very good picture, but that dryer with the under the box is actually a heat pump dryer. I'm giving you examples. That is an HRV that has a heat pump on the left-hand side inside that box. And it can heat and air condition a house, as not to a great extent. It's mainly used to control humidity in the house. So if you have excess humidity, it will pull it out like a dehumidifier, but in the process, it creates heat. So if you see those 2 tubes, there's also in the middle there's a tube. This is not completely installed yet. If you have excess moisture that comes out of it, and we'll talk about that later, excess moisture goes into the drain lines to the city sewer line in this case. And I'll tell you, we'll talk about something a little bit later with this kind of a heat pump. I'm going to introduce you to thermal batteries because they're part of what heat pumps do. Heat pumps, as I said, take heat from where it is and move it to where you want it at a higher temperature and release it at an efficiency of about 300% on average. So phase change material are like those little hand warmers you use when you go out in the cold. You squeeze them and they release heat. There are now systems you can purchase that you can make all your hot water with a heat pump connected to a phase change material battery. Kotzebue is looking at this right now. And one of the things they're doing is thermal dumps. So if they get an excess of solar or wind and the city can't absorb it, they can push their electricity right into people's houses and give them reduced cost heat with direct electrical input that would heat this material, and you can then distribute it through the house as either hot water or heat. It's a really amazing technology. And they're, instead of an 80-gallon tank, it's a small box that's probably 40 inches tall, 20 inches wide, and or 20 inches deep. It would fit under a countertop, and about 16 inches high. So really, really cool materials out there now. So I want to talk about the refrigerants that heat pumps work from. There's a lot of discussion these days about the different kinds of refrigerants and their detrimental effects on the environment. So R410A is the most common heat pump refrigerant that we have. It's on the list of the refrigerants that have high global warming potential, that's GWP. And that one is going to be phased out soon because it when it releases, not if it releases, because it will release, but when these systems do leak on a regular basis. I just want to be clear about that. Because they have torqued fittings that connect the outdoor unit to the indoor unit with copper tubing. And in cold climates, especially what you have up there, cold and then hot summers, it changes the way that torque fitting, it doesn't always stick, and you get loss of refrigerants. Everybody's had a refrigerator that went bad at some point. Everybody's had a freezer that went bad at some point. We need to stop releasing these high global warming potential refrigerants into the atmosphere, because that is what's causing climate change. It's one of the major factors. The second problem with these refrigerants are that they are not natural. They're custom made in companies like DuPont, Chemours. There are a number of manufacturers that make these. The heat pump industry has not been very happy about the recent news that the release of the refrigerants that are still left after you take out the R410As still are potentially getting into they degrade to the level chemically that they become PFAS. We've always thought that PFAS was strictly from the firefighting foams. That is not the biggest contributor. It's coming out now that these refrigerants, no matter which ones, if they're not natural refrigerants, so like carbon dioxide, propane, what are the other ones? Gay, can you think of any other natural refrigerants?
Hang on, maybe the audience has
Ask anybody.
other, what is it again? Refrigerants?
Natural refrigerants that are not man-made.
Ice. That's about my technical level.
Okay.
Anybody?
Ammonia. That's the one ammonia is one of them. So ammonia
Kevin,
is a great refrigerant.
Who unmuted there for a sec? Was that you, Kevin?
Yeah,
ammonia.
Ammonia. Yeah,
okay,
so we use that.
You win.
Yeah, good job. You get a sticker.
Right on.
So ammonia is really great for refrigeration. In fact, in Seattle, I was a contractor in Seattle for years. And I got to go into some of the old ice houses and fish warehouses, and they had these gigantic compressors that ran off ammonia to keep the fish and the ice cold during the summer so they could sell it. This was like they had electricity, but they didn't have nice refrigeration like we have now that you could run to Costco and buy and stuff all your fish into. I'm talking about industrial size cooling systems. So the natural ones do not break down into PFAS components. And so I'm really, really concerned about that. I'm working with Andy Baker, who did the Sea Life Center down in Seward. It is a carbon dioxide heat pump, and it heats that entire facility from seawater in Resurrection Bay. He's got another project coming up where they're going to heat buildings the same way, a little bit different style, but he's the one who turned me on to this problem of PFAS about a month ago when I was in a meeting with him. And he sat down and wrote out the chemical equations for me and said, this is the problem. So you can do all the reading you want on that. I'm not going to beat that horse anymore. So the R410As, all the heat pumps today, the mini splits, are producing about 100 degrees. I was in Ambler when I was doing heat pump assessment to put a heat pump in every home. I did energy audits on each house. So I was staying at the BPSO building, and they have 2 heat pumps, one in each unit, that actually have 3 solar panels attached to each. And I just, out of curiosity, I had my thermal imager with me, and I wasn't sure what the temperature. It didn't feel hot. So it was about 102 degrees coming out of that high wall head. So it made me realize, well, that's the reason they are running all the time when they're on, is it's not a high temperature, but you can set the heat at anything from 50 on up to 80, I think. And the average temperature, that 100 degrees, by the time it hits the thermostat, tells it tells it that your set temperature of maybe 72 or whatever. So carbon dioxide can make 145 degrees water down to minus 27 degrees. It can, so the project I have in Kotzebue, which is one I'm going to show you later, is using the Sanco 2 air to water heat pump. And I was giving a tour of it one night about 3 years ago. It was 35 below. And I was inside with a bunch of people, and I said, hey, did anybody hear that? And they're all looking at me like I was crazy. And I said, the heat pump just turned on outside, and it was making 145 degree water to heat that space. It blew my mind. So it was making, at the time, 8,000 BTUs an hour. But from 3 degrees up, it is making 15,400 BTUs an hour. I guess the takeaway from that was, for me, that it has potential. It works really well down here in our region in Anchorage, and down, I've got units in Kodiak. I've got a couple down in Sitka. I've got them all around. And they do work down to minus 27. We had a minus 20 some couple weeks ago, and they did well down here. So the only issue is that as temperatures go down, any heat pump's capacity to output, the output will drop with lower temperatures. The 410 type, the non-natural types, are getting better, but they're still not able to consistently make lower than about 20 degrees. without going into there are some of the outdoor units that have, they're on blocks on the ground, they're on stands, and they have two full compressors basically inside of them, and they're gigantic. So I think they're actually getting some better production out of those, but they're not using carbon dioxide, and I choose to use more natural products in everything I do with my high performance buildings. I just think it's the right way to do it. So I just covered all of that, I believe. Yep. So there's some regurgitation of earlier. So once you're making hot water, you can do whatever you want with it. So I had the discussion with the supplier that I have for the Sanco 2s that I didn't think people were going to spend, $5,000 to $6,000 or more for the material for the units themselves. Then you've got labor on top of it. A lot of people are doing them themselves. I'll get to that later. But I didn't think people were going to spend that kind of money for a water heater in Alaska. So I said, how do I get heat out of this and make that part of why I'm making hot water in people's houses? So I'm going to take you through a house. Before I get to the main project, I'm going to take you through how I would do a house, and I've done a bunch of them. I'll show you an example of a house that's done a deep retrofit that is being run by that Sanco 2 heater. So you can see at the bottom those different types of refrigerants. There are 3 of them in the R744 is the carbon dioxide. It has a global warming potential of 1. Everything else is judged against carbon dioxide for its global warming potential. So the new one they're trying to get people to use is 32. That's only 675. The 410A is 2088 on the scale for global warming potential. That is just really out of control. So it looks just like that other one, right? It's a compressor behind that white plate on that side. There's a big fan, and there's a radiator that wraps on the left side. It's an L shape. It goes back behind the fan. And what that fan is doing is it's pulling the air from underneath it, from around the sides, and behind it at the top, and pushing that air that's outside through this radiator, which is moving that temperature into the compressor, putting that temperature under pressure and raising the temperature, or putting that refrigerant under pressure, raising it in temperature, and going back through. I'll have a better picture of those pipes on the right-hand side, but going back into the house to a tank where we're storing 145-degree water. The really nice thing about these machines is they're very simple to install. It's like putting in a water heater. There's no vacuum pump needed like mini splits have. All the refrigerant is in the outdoor unit. It does not move from there. You're simply passing water across a big heat exchanger that's combined with coils that are the refrigerant. You can use PEX, you can use copper, you can use whatever piping you wish to use, but those are the 2 main ones. The nice thing at 15,400 BTUs an hour is we're using a very small amp double pole breaker, 15 amps, to make that kind of heat. which you can do anything you want with once you have it in the house. These guys offer, I only buy their stainless steel tanks because I don't want problems, because a lot of my projects are remote. I don't want to have glass line tanks. I just don't think it's a reasonable thing that people would want in their house, because once you get a crack in it, then you get a rust on the steel itself. Stainless is a much better product for this type of thing. They come with an outdoor safety shutoff, so that if you need to turn it off and do anything inside of it, you could possibly need to swap out the pump itself. You might have a motherboard that has a bad diode in it. You have to get into it. So you have a service cutoff right out there by the unit, so that any technician who comes there knows that they have to turn it off, so they don't get hurt when they're working on it. They also used to come with a voltage regulator. I'm trying to source those again. And they actually had, the shutoff actually had, if you've seen on an RV, that big twist lock, 240 volt connection that you would connect to an electrical stand at a campground. That's how you can hook up your own generator if you want to make heat with it. If you just use candles or something inside in a power outage, you can still make heat out of these things by using a generator. A Honda 2000 watt unit would do it. I went too far, sorry. So that's the product. These tanks are made in Australia. The main units are made in Japan, where they were invented about 25 years ago. And ways to distribute it, if you're going to use it for heating, which is my total goal, is you can run radiant floors with it. I've got a couple of projects that have that. As I showed you, that high wall unit, they make a hydronic version of that rather than the refrigerant based copper tubing. Right from the water heater, you take the water and run it up to your high wall unit and back, and it creates heat in your house. It blows probably 140, 135 degree air down into the space. So that's where that discussion I had earlier was between distributing with these high wall heads versus the mini split high wall heads that are only putting out about 100 to 103 degrees maybe. You can also use radiators, and you can also put it into ductwork, and I'll talk a little bit about that. So these are really good in buildings that are high performance buildings, and that's where I'm going to go next. Well, this is showing the different ways of distributing the heat. So you see where the cold water is coming in. That could either go into the unit itself, which is follow the 120 red line and up. That's a fan coil that you can distribute the heat with. But then it would go back to the heat pump itself to get reheated, and then work its way back and warm up that phase change material or hot water, whichever it is. So the 50 degrees is cold water coming in and coming out as hot water from that same box. You can power it from grid power, or you can have solar directly into it. If you have solar on your house, there are different ways to do it. In Kotzebue, we ran it. It was at the radio station for a number of years. Ran for, I think, 2 or 3 years, and just as an experiment. And they finally moved it over to the Chukchi campus, and that's where it is now, and they've actually been using it. So that'll be the main discussion in about 10 minutes. But you can see how the heat can also, that red line going up to that expansion valve, that's hot water going into the house. So it's a very, very versatile heat pump. You can do a lot of different things with it. So there's the underneath the cover, underneath the hood. The red line is going in with hot water to the top of the tank inside in this guy's basement. And the blue line is coming up from the heat pump and going into the heat pump and getting hot and then coming back and going back down the red one. There's the tank down below. You can see that the hot water on the right-hand side of that tank is coming into the top of the tank. I'm sorry. Down at the blue one on the left at the top is going into the top of the tank with the hot water. You can see the hot up above. And the one that it looks black, but it's actually blue going up from the bottom on the left in that shadow and then up next to the white one. That's the one that's going up and going outside to get heated up, and then it's coming back and going down. The red one is actually the hot water that's going to the house. So there's that dryer again. That's got a heat pump in it. And the Minutair I'll talk about in a minute and how that is, well, I'll just go right to it. So in this house, we are taking the heat from the Sanco 2 at 145 degrees. And these two companies agreed on a copper fin tubed heat exchanger of 8 inches in diameter that will transfer heat into the ductwork. The Minutair has self-adjusting by pressure fans that distribute the heat from the heat pump hot water into the ductwork and heat the house. This entire house is heated with that simple system. The outdoor heat pump heating the sand and tank, that hot water going to a heat exchanger and putting that 145 degrees into the house with the pressure, with the fan pressure from the Minutair. The Minutair, if there's not enough heat in the house, it will sense that there's not enough returning heat through the ductwork coming back to recycle, and it will say, it's too cold, returning, turn the heat pump on inside of me. There's another 6,000 BTUs. So it's pretty basic technology. This guy put this whole system in by himself with my guidance, and it's been running for 4 years, and he is so thrilled. They have no gas at their house. They're up by a Klutna Lake, and they asked me to design the house for them energy efficiently. And they are just thrilled. They don't have solar yet, but they will be net zero. They'll be lower. They'll be net negative when they have solar in that house. So high performance buildings, and this is what I made for him. They have about 80% lower heat demand than a code built building. So if you have a house that needs 100,000, let's say 50,000 BTUs, that's more common. If you can get that down to 10,000 BTUs or lower, and his house is at 8,600 BTUs an hour, heat pumps work really well. If you're higher than that, you can do one of two things. You can put a second heat pump in to help the original one, or you can have the heat battery that I showed you has a direct electric 240 input. So it would be a direct electric input, not a heat pump, Remember, they're 300% away from each other. So I would consider putting in a second heat pump. Or it depends, you know, for you guys up there, it's really cold up there. A second one would be a better option. It's always good to have redundancy. That's kind of one of my feelings. So the blower door testing on these buildings should be less than 1 air change an hour. The house I'm describing to you, his blower door tests, for those who understand what those are, 1 air change an hour. His is 0.16 air changes per hour at 50. The passive house level cannot exceed 0.6, and he's at 0.16. It's a completely airtight building, and that's how he got the heat loss down, is by making it super efficient. He's got 12 inches of cellulose on the outside of the house, 20 R23 in the walls of his house, and he's got 18-inch heels on top of the walls for his rafters, for his trusses. And in the middle, at the peak of the trusses, he's got 3 feet. It's all completely dense packed cellulose. He did it perfectly. I couldn't ask for anybody to do a better job than he did. And he'd never built a house before. He was just very diligent. So this is a project that's here in Anchorage. 1954 home was purchased by a friend of mine. He wanted to get it down to net zero, and he wanted to put the same kind of heating system in. It requires triple pane windows. All of these buildings do. Exterior wall insulation, you'll see in a second, and complete air sealing, and he will be under 1 air change an hour. His original design heat loss from my energy audit was 47,000 BTUs, and he will be down around 15,000 BTUs. And this is how we do it. These are products that are coming from Germany. That's a duct intake for the Minutair ventilator. But what I'm showing you is how that duct is air sealed to the outside of the building. The cellulose is behind that black fabric. And this, what you see that's in a square of this blue tape is a neoprene gasket that keeps that that duct from leaking. So that's how it's these kind of things that got that house so efficient. His windows, a triple pane window. These are pretty good windows. 0.16 U factor. Solar heat gain doesn't really matter. He's in the trees. But a double pane window starts at 0.21 or 22. Most houses in Alaska are having 0.27 or 0.8 U factors, not the solar heat gain, but the U factor. Those are not great windows, as you folks may know out there. They're even worse down here. Many of the builders are putting in 0.31 windows down here. I'm really dismayed by the trends in this state. By the way, switching from double pane to triple pane windows, the cost difference is about a 3-year payback in savings. So it is worth the investment. It's only a 3-year payback, the differential between double pane and triple pane windows. So this is a house in Rogers Park. It's 1952. It's a Cape Cod. This roof was a concern for us of how we were going to better insulate it. Where you see between the 2 windows inside, there are sloped ceilings on both sides of the house, this side and over the ridge. And there's a little knee wall right where those windows are. And if you haven't seen a Cape Cod, I can't really explain it any better, but the problem is that between the bottom of the windows up to the flat part of the ceiling, which is up at the top of the wall where the windows come and meet in the back there, they were only able to install initially R4 in a 2x4 wall, and that's in fiberglass. That doesn't cut it here in Alaska. I'm sorry. I don't care if we're in Alaska, in Anchorage, or down in Sitka, or somewhere further south. R4 is just not a good insulating ability. So that's what happens. I'm sure we've all seen that. The heat loss has essentially melted around those extensions for the two windows above and caused the ice to build up down at the bottom, ice damming. But you can see how uneven the snow is. That's from heat loss. That's not from shoveling. That's not from wind pushing snow around. It's completely based on heat loss. And you can see the icicles, and they were much worse than that. But that's just the best picture I had of that ice. So this is how we air seal a building. We take these fabrics from Germany and we tape them to the body of the building at the bottom of the house. You can see the foam there he's using on the outside of his foundation. These, by the way, are ICF foam poured concrete footings, or walls actually, but he added additional foam to the outside of them to get a much better R value. So we're air sealing that building completely. Every window, every door, every penetration, for lighting, for hose bibs, for dryer vents, are all being taped so that we get really good air sealing, because we will have an HRV that will give us fresh air all year long, and it will do it very, very efficiently. It's the most efficient heat pump in the world, the most efficient HRV in the world, because it has a heat pump in it. So you can see how deep the windows are. This is that house that I explained earlier that has 12-inch trusses on the outside. Those windows are built into the 2x6 area, and it's completely air sealed. It's completely water sealed, and it is vapor open, so that any moisture that gets behind this can wick out to the outside of the building. They're airtight, watertight, but vapor open. It has a perm rating of 38. Most air barriers in a house, and the one that's on this one, is down around, I think, 3 or 4. So you want to stop it from coming out, let the HRV do the work on the inside. But if there's any moisture that does get through, it will quickly go through this material. We don't have any problems. So if anybody knows this man, so I think some of you guys might, this is Griffin Hagel. He runs the Housing Authority in Uktiavik, and he's now the president of Cold Climate Housing. He's an old friend of mine. He pulled me in on this project because he knew I was doing this kind of work. So I'm going to talk to you about the air sealing. You see the material on there. It's actually on the roof. It's under the 2x4s. The reason we did that is he wanted to build an insulated over roof. So on top of this 2x4 on the flat, we didn't want to have thermal bridging from inside. So we had a contractor come in and build a whole new roof on all these components of 2x10, and in between those 2x4s is rock wool, 1.5 inches, so you don't have any heat coming up through there, and then up through the dense packed cellulose of 9.5 inches. And then the Mento is over top of that as well, the black material. And then he put a metal roof on last year. And you can see the windows haven't been done yet. This was a couple years ago. This project's taken quite a while. But I love that picture. That's the ghost in the neighborhood. And there you can see the overlay of the Mento, and then the framing that we put up so that if there is any moisture that gets behind the roofing, it will drain and run down that roof and just drip down into a gutter and be of no consequence. Completely airtight building. I took that one about 2 weeks ago. I love the look of that because that's a whole winter's accumulation, what hasn't sloughed off on its own. But you don't really see any low spots because there's virtually no heat loss in that building with that overlay of a roof. The exterior is 2 layers of 2-inch rock wool. There was an R4 in the cavities inside the house of the old house. So rock wool is 4.2 per inch. So that's about 16.8 plus another 4. So it's an R20. But the big reason we did this was we stopped all the thermal bridging from the studs, the headers, and the rim joists. The rim joist at the bottom and the rim joist between the first floor and second floor are always huge heat loss areas. And we just don't have that anymore. We also don't have any leakage of air like we do in a typical rim joist, where they don't bother to put an air barrier aligned with the thermal barrier. Back to the right there, you can see the Sanco 2 on its rack, and it's back there chugging away. This house is not complete by any means. You can see the upper window on the left has rock wool in the opening. The other one's not even installed or cut out yet. The one up at the top right is not even insulated on the outside. It's just got what was in there originally. And his heat pump system is carrying the load pretty well. When he gets it completed, it will be running completely off electricity. He took the gas meter out. That will never have gas again. This is an internal method of doing rock wool. I won't go into that too much. This is another method of doing interior rock wool or interior insulating and air sealing. And there's the Sanco 2 heat pump again. So the need in rural Alaska, Kotzebue started putting heat pumps in I think it was 16 or 17. I put 1 or 2 in each of the villages. So I think we have 15 of the Panasonics up there. They're mostly still running. I haven't heard anything since then about them not running, so I'm assuming they're running. They had some extra money in the budget that year. It was use it or lose it money. So Ingemar called me and he said, we have an idea. We want to tackle food insecurity, and we want to do a hydroponic growing facility. And we already have one here in Kotzebue, but we want to do something that doesn't use fossil fuels directly. So the one that they were using it's not running anymore. I'll get to the build of that later. I've got a special section for that. But they wanted to be able to grow local foods it was originally going to be at the senior center. So they wanted it to be something that the elders could do during the day in the wintertime, go out there and play in the garden inside. And so if you haven't seen this before, this is it. So we are solving the high cost of food and food insecurity. In cold climates, heat sources are expensive. So the other option is electricity. Another problem is water. Water's necessary for hydroponics, right? The best way to work with your water is to recycle it the best you can. And I'll get into that in a while because the facilities have really high levels of humidity. And if you've got really expensive lighting systems and mechanical systems that rotate trays up and down in the system, the moisture is going to short circuit all of those over time. It just it's too much wear and tear on the electronics in a system like that. So you have to have a good ventilation strategy. I think they were using like a gable end exhaust fan from a greenhouse to get rid of their moisture, and they were using a Toyotomi to heat it. You need to make sure that you have a heat distribution strategy for the building so that your plants don't die. And you also have to have an airflow strategy. Plants need to wave in the wind or they don't get healthy. That's a fact of every plant on the earth. They need to have some wind to help them get stronger. They resist the wind, they get stronger. It's just like, watching a tree grow. They get stronger and stronger and they grow tall and they don't fall down for the most part. So Ingemar asked me, he wanted to use the Sanco 2 and he also wanted to try the Sun Bandit Solar. So these are pretty interesting products. I'm the one who recommended the Minutair because I knew it had the heat pump in it and I knew it could control moisture. And I'll talk a little bit more about that later when we see some pictures. The Sanco 2 is using CO2 as a refrigerant, which passed the Montreal Protocol of not putting gas. If there's a release of refrigerant, it's not going to, with its global warming potential of 1, be a problem in the atmosphere. At the time we did this one, that unit was only rated down to -15. It's now rated down to -27. And as I said, this one was running at -35 and still making heat. It works in the cold times of year. He's actually got it set up, the installer set it up using glycol. We were told to not do that, and we did it anyway. Because why would you guys up there in the cold want to risk freezing your pipes, right? So it's not being used for potable water by any means. And so the contractor did that on his own. I didn't say anything. It's been running ever since. The only problem they had was a couple of years ago, they got an air bubble in one of the hydroponic on one of the heating lines, and it stopped moving heat into the radiant panels. Other than that, it's been running forever. It was the first UL and SRCC certified, the Sun Bandit. It's a really interesting solar hot water system. It's using, instead of solar thermal, where we're pumping glycol up to the roof and waiting for the system to fail and then crack the panels on the roof. This is just using PV panels going through an inverter, converting the DC to AC, and heating up the water tank with a traditional element for hot water, a 4,500 watt element. I've done a couple of them around Alaska. I've got 3 or 4 systems out there. They're all running beautifully. It's a pretty neat system. And for me, working in Alaska, durability means everything. I can't justify making trips out to villages to do a repair. If I can guide somebody on a simple system to do a quick repair locally, these are the kind of products that I chose to carry in my business. And I have not had a problem with running my business that way since I made that decision.
Mark, this is Gay. I just wanted you to know you've hit the hour mark. I'm not saying
Okay.
to stop, but just so you know where you are. And
Okay, I'm
people-
really close to the end.
Okay, all right.
Okay.
No worries.
So the Minutair, the Minutair does the heating and cooling. It does the air exchanges from the outside. it pre-warms the air that's coming in. It does HEPA filtration at MERV 15. It's got 2 sacrificial filters as well that collect particulates that are way bigger than HEPA, so you don't have to worry about them clogging up your HEPA filter. But we can use this to move the air in the building, keep the plants moving, being blown by the wind. And that heat pump inside of that, since it's really damp in there with the hydroponics, it actually is a dehumidifier. And I told you earlier, there's a pipe that comes down out of those 2 pipes on the bottom of the Minotaur. The water that drains out of there is perfectly pure. And they put it into a barrel and they recirculate it through the hydroponic system. So they can bring, in nice weather, not 40 below, but in nice weather, they can supply inside of that building because it's 73 degrees every day of the year. They have enough water in there to do their hydroponics, and they're not risking ruining their electronics. The low set point for removing water is 30% relative humidity, and it does a great job of it. There's never been any evidence of moisture problems in that building. So this is the building itself, in case you didn't know. They were really brilliant. They found a 26-foot reefer van. They lined it with 4 inches of EPS foam, and then they put up these radiant wall panels with red PEX tubing, and they put a floor in the same way, and that place is toasty. I almost slept in it one night because our flight got canceled, and the hotel was packed for the night. They did let us they let us have our room that we'd had the last couple nights. So we lucked out on that, but I had every intention of sleeping in there that night. So the Sandon runs in the coldest time of year, and the Sun Bandit runs when, like right now, when you're starting to get sunlight up there. Whenever there's sunlight, it's making free hot water from these solar panels on the side. And as long as that satisfies it, the Sandco 2 doesn't have to work until the next fall again. But it works when it needs to. There are immersion backup heaters in the Sun Bandit tank. There's one 6 kW backup heater in it. It runs if it needs to. We don't, but based on the, I'm going to go back up one. Based on the cost of operating, Ingemar did a calculation, and in the winter months, his average daily cost of operating this was $9 a day. So do your math, see if that's a worthwhile cost of heating against the cost of $6 or $11 a gallon oil up in your region. So there's the system set up. You can see the radiant wall panels. There's the Sandon tank. Great little system. There it is from the back. Still, after it's been used. Well, it hasn't been used at this point because they still have that heater from when they were building the inside of it, putting in all the lighting and stuff. They hadn't got. You can see the duct up in the upper right corner. So that's the airflow into the space, and then it returns back out near that door and goes into the Minotaur HRV and gets reheated. So it's always moving the air, even though there's heat in there from the radiant panels. It does circulate air. So, and the fans are there to help circulate, help move the plants too. So this was the day they moved it to the university campus. And you can see the heat pump hanging on the back. And this, I don't know who these people are. They work in the culinary department at the campus there, but they've had some really great, they've gotten potatoes, they've gotten peppers, they've gotten all kinds of greens out of it. And I think they sell them to the hospital and the hotel. So you can see the lights. This is a great use of a heat pump. If anybody knows Brad Rich in Kiana, he is the most innovative recipient of my award for best extra use of a heat pump. This is his shed on the front of his house. His front door is to the right, but he wanted us to put this unit inside the shed since there's no door on it. It's just an opening. He wanted to be able to dry his meat and not have two things. He wanted to have the air from the airflow to blow the meat dry, but he also wanted to blow all the flies off of the meat. I love it. It's the most inventive use of a heat pump I've ever seen. He sent that, this is a new one he sent to me a couple weeks ago. So it's just a great way to end the discussion of heat pumps. So if anybody has questions, take a quick picture of that. Feel free to call me or email me. So anybody got questions? I'm sure they're going to be a lot if I have time.
All right. Well, thank you, Mark. I don't know if you can see me back now.
Yep.
If you can stop your screen share, unless, wait a minute, better ask the audience first, if there's any burning questions on any of the pictures she showed. Let's see if we can get you so we can see you this time. If you unshare, just click the green button on the bottom. That says share screen. You want to click it again. I don't know what it's like in your Apple.
Oh, you're asking me to do it?
Yes, and then it will
I have a
get rid of
question.
your,
I have a green that says you are screen sharing.
I
And
don't
then
know
next to it is a
anything.
red one that says stop sharing.
How about, I'm afraid, hopefully it won't kick you off, but there should be a toolbar, a
The
Zoom
toolbar at the
toolbar.
top. There's a toolbar.
Go to the Zoom toolbar at the top then. I mean, it's like, should be its own toolbar just for Zoom controls.
Stop
Yeah.
sharing. Stop sharing.
I'm so sorry, I don't know Apple. Stop sharing, see what happens.
It will
Hopefully
probably
we don't
boot
lose
itself.
you. Okay. And if you can find the one that has your video on it, we can take a look at you. It's been very mysterious with you in the dark. You are getting some questions, so it would be good.
Start video. Let me go over here on this other screen here.
Okay.
Got me?
Hey, all right. Well, there you go, everyone. There
don't
is
see
Mark
me.
Houston.
Hi,
So
everybody.
thank you for giving us your presentation, and you've already got thank yous, so, and thumbs up, and a question from Jim Dory to everybody. You mentioned using water to the heat pump outside. What happens in a power outage at sub-zero temperatures, no generator? Would it freeze up and cause damage?
Absolutely. Absolutely. So, as I said, on this particular application, since we're not using potable water in this trailer, nobody's going to drink it. The contractor who installed it put glycol in. So the glycol runs through all the PEX tubing to heat. It goes to each of the water tanks or to each of the storage tanks, and it goes to the outdoors from the Sanco 2 tank and back in. So it is using glycol out and back. I am so glad he did that because it would have been an absolute nightmare and nobody would know what to do. So on this down here in Anchorage, I'm still worried about it down here. I know at some point somebody's going to have an outage at sub-zero, and it was, blowing like crazy. They didn't want to go out there.
Jim says he understands. Just curious if glycol was standard.
I think he did a 60-40.
Mix.
Food grade.
Like the RV and food grade? You mean like RV antifreeze? Okay.
I think that's what he put in.
All right. So like the Starbright or whatever that stuff is.
Yeah, I wasn't there when he did it. It was a shock to me, but I'm so glad he did it. So I was told by Sanco too at the time that I would void the warranty. I think I made a good decision because it is still running. If I had done it the way it was supposed to have been done, it would not have survived. We do have a heat tape that goes on the pipes in and out of the facility. That's on every job. And we also have these purge valves that are kind of like when you have to turn your sink on and let it drip so you don't freeze your pipes. It actually has a wax material in it that when it gets cold, the wax pushes the valve open and it lets it start dripping, so that you've always got, since a house is under pressure, there's always water pressure pushing into the water system through the tank itself. So it will always keep it from freezing up. But I didn't want to deal that. Sounds like somebody could use radiators instead of blowing heat from one of those high units. Yeah, absolutely. You can use radiators. So I do on every house that someone wants to buy this system, I make it mandatory that we do an energy audit, because I want to know what their design heat loss is. It makes sense to do that. I know it may not be easy for you guys out there because you guys don't have a rater. I believe there is someone getting certified in Bethel. I'm not sure, but that's probably more expensive than us coming from Anchorage to get them up there.
I would think so.
I've done a number of ratings for the housing authority there. So, and in fact, I did one. I was up there in October to do one for a house sale. They needed a PUR 103 to sell the house. And so I went out and took care of that for the owners.
I have a question.
Yeah.
How? Because I am not, Kaluza did a blower door on our house. Couldn't get it to register pressure difference. Done a lot of work since then, but not expecting miracles. I've done many blower door tests for housing authorities. In the chat.
Yep, I see it. And if you have access to a fan, I would do it again. That's the hard thing is, all the housing authorities have their own fans because they do weatherization. So you should be able to borrow one. You also need to know how to do the ACWORM modeling in the software from Alaska Housing, because that's how you learn what your design heat loss is, by putting in the right garbage, not the wrong garbage in, garbage out. You got to put the right data in, right dimensions, right insulating abilities, and then plug in the volume with the blower door results. That's how you get your design heat loss for the building.
So thank you for that. And here's my question, because it all looks like magic to me. So you're saying that if it's 15, 20 below outside, there's still heat in the air that then somehow it magically, with electricity, turns it into something that makes the inside of the hydroponics or the inside of your house warm. How? How is that possible?
Under pressure.
Okay.
Compression cycle.
Okay.
That's the magic. It puts it puts the refrigerant, whatever it is, under pressure. The temperature of that refrigerant rises, and you move that heat to another place where you either want it to heat your home or where you don't want it, as in an air conditioner, pushing it outside of your house.
So the electricity is not to warm it up or anything in my
No,
simple
the
brain, but it's
electricity
to apply
runs the
pressure.
machine. It makes the pressure with a pressure pump, with a
Okay.
scroll pump, and it makes pressure, and then it has these valves that open and close. So it opens the valve where you want to express the heat, whether it be into the hot water or into a high wall unit like that, to express the heat to go into the house as warm air. It's magic.
It is magic. It sounds like
It is magic.
pure FM magic. So that's
It's really amazing.
like FM radio magic.
Yep, magic.
Hmm.
Absolutely.
And so is it what constrains it? Is it for out here, is it the cost of the electricity, but you said you could have a solar array or something to.
So are you guys, what's your cost per kilowatt?
Audience is going to have to answer that. What's the price per kilowatt
Audience?
in Nome? Anybody?
You're 21. That's what we pay in Anchorage. So you guys are on PCE. So what's the cost of
Thanks, Jim.
oil?
Phew.
6.50
Yeah,
a
I was gonna
gallon.
say.
It's a no-brainer. The heat pump will work. It will save you money. So in all of those installations we did in the Northwest Arctic, the units they chose were very inexpensive mini splits. They only worked down to 5 degrees. Ingemar wasn't concerned about midwinter. He wanted to give people financial relief, like the people in Ambler who are at $16 a gallon this year. And they've got, I think they're around 35 cents a kilowatt. They're saving thousands of dollars a year by just running them in the spring and fall. Thousands of dollars. They have like a 2-year payback for those mini splits they put in.
How much does
One
one
great,
cost? The mini, like that in that example.
well, those mini splits they put in, they did 60 of them, I think. I think the cost came around 6,000 each. They're a low budget product, but you've also got shipping. You've got crews that you have to pay to be out there installing them. They had to put solar panels, 3 solar panels on each house. So those things run free. This is a kicker. They run free to air condition your house because they have solar panels that run them when there's sunlight. So all summer long, they get free air conditioning. Kind of a nice bonus.
If you live somewhere.
Well,
we've gotten hot. Yep. We've gotten
well,
warm.
so upriver is
Yeah.
considered interior.
Yeah, interior.
Right?
Yeah.
So
We've seen 90s here.
oh
Nome.
yeah, absolutely. We were putting in one of the heat pumps in Shungnak. Billy, shoot, what's his last name? Anyway, he used to run the cruise up there for weatherization. When we put it in, the 2 guys I was working with had to fly off to the next village. The pilot came back and got me. So in the meantime, he and I were watching a movie, and he was complaining about how hot it was. And I said, "Hey, Billy, it works in the summer. It's an air conditioner." And he goes, "Really?" I said, "Yep." And he said, "Oh, my wife is going to love that so much." Because it's really, they have a 2-story house. It's hot upstairs. You can't sleep because you can't open the windows because you got too many bugs. So they now have air conditioning. Everybody that got them now has air conditioning as a benefit.
Yeah. Hey, Mark, this is Phil down in Seward.
Hey, Phil, how's it going?
Oh, not bad. Jim Dory asked me if I had time to stop in. So I guess some of the economics, what really pays off is you have 750 kilowatts of PCE. If you're only using 500, because you're very, frugal on your electric use, that extra PCE is just like gold for that heat pump. So the
Absolutely.
economics work out really well. I think what I encourage people, if you really want to play with the economics, our good friend Alan Mitchell
Yep.
put together this heat pump calculator. And if you just Google Alaska heat pump calculator, it should come up and you'll get to pick your own community and it'll have your utility cost, electric and oil costs in there and all your weather data. And it really kind of give you a ballpark. And it's going to ask you how much electricity you use in the winter because it is very critical. I mean, you're going to find, a good efficient mini split's going to use, like 14 kilowatts to replace a gallon of oil. And, it might use 18 or 20 during the coldest part of the winter and only use 8 during, spring and fall. But on average, it's probably going to be around 14, 15 kilowatts. And you're going to find that once you start getting down to 10 degrees, 5 degrees, like Igmeyer figured out, that's kind of where things start breaking even because you're probably using up your PCE.
Yeah.
You have that credit. So interesting economics. I mean, I've played numbers in Gnome and, it works.
It works. It
And,
does.
the newer heat pumps are all rated down to that 15, 20 below now, but
Yep.
pure economics kind of says, you might want to be thinking about turning on the old Toyo at, 10 degrees or something. And
I would never tell people to take out an existing system.
oh yeah,
Right? We always want redundancy up here. But this is a way to give you financial relief from the oil. And it's by far the best way we've found so far.
All right.
Yeah.
Mark, may I ask, I'm sorry if we're going longer, but
No,
I'm
that's
just
okay.
curious.
If you've got questions and Mark can handle it.
All right.
He hasn't given up yet on us, so
I
Go ahead.
appreciate it.
I might have to bow to Phil on a couple of questions.
Well, I'm just, it seems like sealing the envelope is huge.
Absolutely.
For air exchanges, do you subscribe to any best insulation practices? Thinking exterior, like the remote system or
remote. So there are different ways to do it. I happen to be a more natural products kind of guy. Because you're building a very tight house. But I think we shouldn't be putting oil on the outside of our houses, as in foam, because all the foam products are made out of oil, right? Isn't that what we're fighting? Oil as a contaminant for the globe. So it takes a lot of energy to make foam, and it takes a lot of energy to move foam from one place to another. And it is inherently made out of oil in the first place. So the global warming potential of that is really bad. The carbon section of that is really horrible. So I like cellulose myself. It's easy to work with. It's the least expensive kind of insulation you can use. When you do it as a remote wall, you stop all the thermal bridging through the headers, the studs, the rim joists, everything. And it gives you an opportunity to put in much better air control with these newer building wraps from Germany. That's how I'm getting these great numbers on the blower door testing, is that material. I also really like rock wool, and there's a new product out called Timber HP, as well as hemp. And so they are all available in blow-in, bat, or board form. So kind of like foam board, but they're made out of hemp, they're made out of rock wool, and they're made out of the tree. The Timber HP is it's kind of like foam rubber in its consistency. It's a really interesting product. I really like it. We can't get it up here yet, but it just came on the market this January.
what's it made out of?
Huh?
What's it made out of? That's like foam
It's
rubber?
made out of sawdust that they they spin it into a material, and they add it's paraffin, and that binds it together. So it's actually like foam rubber. It's the consistency of foam rubber. It retains its shape when you push on it. It bounces back. I think when it's on the outside of your house, it's probably not going to bounce back. It's probably going to be pretty rigid.
Right.
But they're all complete coverage of the outside of the building, including the roof and even underneath, like we do with foam board now. But they're just more natural products that are carbon sequestration, and that's really the kind of work that I'm interested in doing.
There's a
I don't
question. Oh, go ahead.
I don't really diss people if they're using foams if they've already bought it, or if they're recycling it.
There is a question in the chat, and that is Carol wonders about the wall blowers mounted high. Why not lower on the wall? Heat rises in draftier houses.
Because they're blowing and they move the air across the room.
Not down.
Down and across. Yeah.
Oh, down and across.
They actually move in a fan motion up and down like this, and then they move back and forth. They've got little machinery in there that makes them, you can either have them stationary or you can have them automatically move around. You like my hands doing the
No, it says, she says eerie. Eerie.
Yeah, so I guess what I would say to that is I would look for solutions to why your floors are cold in the first place.
That's a good one.
Leakage and or low levels of insulation. So you can solve those that way.
And I could add a little bit, some of those mini splits do come, you can get them with floor mounted fan coils instead of the high.
There are a bunch of different.
There are some options out there, but
yeah,
the most efficient ones seem to be the high wall units, but all that's changing so quickly. I don't think any of us can keep up.
It's incredible how much knowledge has come across this industry in the last 3-4 years.
And if Carol would have bought a house that was 120 years newer.
Yeah, I don't know if you can see that, but it says our house was built as a saloon in 1899. Thus, maybe the cold.
Phil, let's go do a deep retrofit.
Hey, Mark,
she's on the historical society list, so
it's
those
a
are the fun
national
ones.
treasure.
You can't change the outside look.
No, but you can still work on the inside. You can dense pack the walls.
Yeah, tell that to Jim.
the beer is still cold in that house.
So are you. I'll have a warm beer. Warm me up.
Mark, can you suggest best sources of information on how to find out more? Are there and also sourcing systems in Alaska?
So I am the distributor for Alaska for these products that I've been showing you. As I said early, when I got Passive House certified, I was at their national convention, and I made the mistake of stepping into a room that was the vendors area, and it was like a kid in a candy store. And I saw all this really cool stuff. And when I came back, I was already doing some net zero consulting, and I found these products down there and have found many others that go into passive house buildings. And I just figured if it's good enough for these guys, it's great for us up here. So I met John Miles. I was, I think, the third Sanco 2 rep in the country. Minutair, I was the fourth. And I got Rockwool a year ago. I badgered them for 6 years until they gave in. So you got to be persistent. And I don't really, I'm 65. I don't want to be in business the rest of my life. But people need these products to do their projects properly. And it's it's hard to find them because you can't just buy, you know, a certain amount and have it shipped up. It's really expensive to ship small volumes up. So I try to do it as big an order as I can at a time.
Complexity of a project, mini split heat pump versus Toyotomi through wall laser 1000.
4 hours, right? For
Yeah.
laser?
Sure.
You could probably do 8 hours for if having never touched it for the Sanco 2.
Okay.
So it's basic plumbing. There's no vacuum pump like a mini split needs. It's all pressured in the outdoor unit, right? And you don't have access to it, to the refrigerant on the Sanco 2. It just does its job. I asked John one day from Sanco 2, and I asked him, you know, I'm way up here, you know, and he used to come up here and sell stuff up here from California. He was selling plumbing supplies. He said, yeah, I know what it's like up there. And I said, I want to know how many of these units have had refrigerant loss since you've been working with them. And he said, the company's been around for 20 or 25 years. I can count on one hand how many got returned for a breach in the refrigerant. They're built to a much higher pressure standard than any mini split is. So they're really stout little machines. And therefore they're not just using regular soldering. They're brazing, and I don't know what the next level is. I don't know that kind of work. Anyway, they're built to a much higher standard to hold a higher pressure, because that CO2 has to be under higher pressure to work effectively.
Do they thank you for that. Is there an Achilles heel with these systems? I mean, Nome is so dusty in the fall time. We just get, I mean, is it something that's going to be an issue?
I was up there in November. Yeah. So I noticed that. I couldn't help but notice.
It's brutal.
Yeah, it was, I could hardly breathe, right, Gay?
Yeah.
I could hardly breathe.
Dusty.
So you have to be diligent and make sure that the fins of the radiator are clean. You can use a shop vac with a brush attachment, and you have room behind the unit to just put your wand in there and suck that stuff out of it.
Okay.
I think the other thing might be that you would be concerned about is maybe cottonwood fluff. Make sure that you keep that out of it, because that really hurts.
Not a problem.
Huh?
Not a problem.
Not a problem.
Yeah.
The only thing that I have had issues with in about a 6-year span, 7-year span with these is every now and then I'll get somebody call me and say the water pump cracked or something like that. So I started to keep those around so they don't have to wait, 2 weeks to get it from California to up to here. So I always keep a stack of those around. But it doesn't happen very often. I just want to be sure that I have them. That's really, other than that, there's really no maintenance.
Awesome.
You should, like any water heater, you should drain your tank once a year to get all the stuff out of the bottom. But it's not like you have an element underneath the tank like you do on an electric or a gas or whatever. So there's really nothing wrong with it down there. It's not affecting performance. You just don't want to have this sludge pile in the bottom of your tank, because it is potentially your potable water.
Is that something you said you would use glycol in?
No. So no. So the glycol I would use in the thermal battery.
Oh, okay.
And it would go into there, heat the thermal battery material, the phase change material, across the two membranes. So across copper tubing into that phase change material skin, and heat that phase change material up to about 135 degrees or 140 degrees. And then it would go back out and go to the house load and then back to the outdoor unit. The Sanco 2 really likes 100-degree delta T. So it's making 145-degree water. It likes the incoming water to be about 45 degrees, and it works at its absolute optimal. Griffin called me the other day and he said, I just got my electric costs from that cold snap. He actually sent me the text of it. He's got an app that's recording his electricity. He actually used less electricity during the cold snap because his returning water to the outside was colder and more efficient.
Wow.
I know, it blew my mind, but I saw that you could see this big dip in his graph. It was just amazing. Yeah.
That's cool.
And
Oh,
I really wish, Phil has this great connection to do all kinds of monitoring on systems. I don't have that pleasure. So I'm relying on people like Griffin who know how to do that stuff themselves, to do all the monitoring. I'm just constantly doing energy audits and filling orders for people for products. And I just don't have the time to be out there putting in electronic systems to do different measurements. It's not my forte. There are plenty of people who do it. I'll let them do what they do best. I'll do what I do best.
All right. Wow. Well, you know what? That I was all so we could do hydroponics is what it sort of sounds like from here.
So that's my
is that
take.
still in use in Kotzebue?
Um, it's not
Or
in
if
use
not,
right
it's not
now.
because of the heat pumps?
It's not in use right now. Maintenance is an issue with everything, and there's one of the other components, they did not do any maintenance whatsoever for 6 years. They never called and asked me questions. So we ended up they're in the process of trying to order a new component. So
Okay. But there's
um,
interest still to keep that going, to keep that.
there
get
is
that
interest to
going
keep
again.
it going, but they need to, I sent them an estimate for the replacement unit.
Okay.
Because since they didn't do any maintenance on it, and they went past their warranty period, they kind of shot themselves in the foot.
I see. Well, so for like, yeah, thank you. I'm just curious because people have been asking and it's a good topic. I'm learned a lot tonight, but for the family unit that wants to grow their own food or whatever. Oh,
Well, it
Phil
depends on the
says
volume
you
they want to
guys have
grow.
oh, there you go. Yeah, there you go, Phil. You guys have over 1 million gallons of waste heat coming off your diesel generators. That's us.
Yeah,
We should use a little.
yeah, district heat system.
Yeah,
Yeah.
pretty interesting.
So that my whole takeaway of this whole discussion today is that use your best judgment, but build a good facility, build a really energy efficient facility first. It's like the old mantra, efficiency first. In my world, I call it efficiency always, because what it does, it drives down the size of the mechanical system that you have to put in. That's the whole basis of the passive house movement. Drive your heat losses down so that you can use a heat pump and solar. And, not everybody up here is going to have solar. But in other parts of the world, there's plenty of use for heat pumps with solar and really good buildings, and they are net zero. The buildings are different in every region, based on your design heat losses and your local weather conditions. But build the best building you can before you start trying to figure out what your heating system is going to be. But if you're going to try to not spend a fortune growing your food, using heat pumps is a really great alternative because of your 21 cents a kilowatt hour. Frankly, that's it. It's PCE comes through.
All right. Well, again, Mark, thank you so much. If you want to stay on for a sec, and any other questions? We're on a marathon now, but it's okay. A lot of good Oh, there's the
Anybody
heat
can call me.
pump calculator website. And you got to thank you very much in the chat. We all thank you for,
Nice. Thanks, everybody.
yeah. So with that, if Carol's still on, she'll be happy to know that the next Straight Science will be on March 20th after the Iditarod, and it's going to be the Godwit research on the Teller Road. So we're going to switch back into
Ooh.
birds. So we're getting ready for this the year ahead with birds, and that'll be March 20th. So stay tuned for that. And thank you so much again, Mark. Again, stay on for a sec and we'll say goodnight to everybody. And if you guys had a good conversation going about all your heat pumping and whatnot. So if you have topics like that that you'd like to see brought to Straight Science, absolutely get in touch and let me know. And we'll it's a science. We'll get it up and running for you guys.
Awesome. Hey, Gay, thank you so much. Mark, thank you so much as well.
Oh, my pleasure. Happy to do it. Feel free to call.
Will do. All right.
All
Have a
right.
good night, everyone.
Good night,
Night.
everybody.